Hi guys, welcome to today's video. We are going to look at some titration calculation. So this is for the level 2 2.1 internal achievement standards, which is looking at the investigation, which involves the component of titration. So you could have a look at the practical, the video that I demonstrated at the practical. Apologies in advance because I was going to do a like a proper one, but since that student was already recording it, so I just uploaded that. So because it really I mean, you can find quite a lot of videos online to show you how to do the practical component, but you really have to practice. And so the best thing that if you struggle with the practical component, just ask your teachers if you could get 10 minutes of the time, and just when you're doing the practice, just get them to stand beside you and just watch as you do it. But like I said, it takes a couple of practices, then you'll master that part. Okay, so the calculation part, however, can be a little bit tricky. You do need to be able to do both the practical as well as the calculation to be to do well for this particular internal achievement standard. So let's get into it. So it's two parts that we're going to look at. So the whole idea of titration is that you get you have a solution that you don't know the concentration of, and what you could do is that in level 2 we only do acids and bases titration. So if you, like, say for example, if you have an hydrochloric acid you don't know the concentration of, what you could do is that you could make a standard solution of a base that you know the concentration of. How do we do that? You just measure a certain amount of it, dissolve it in the water, use the N equals CV equation to figure out the basis the concentration, and then you can do a titration, because you always need to know the concentration of one of the solutions, which is your standard solution, and the two volumes. One is from your pipette, which goes into your flask. One is the titer, which you record from the burette when you do the titration, and then you use a mole ratio to figure out the last concentration. But we're going to go through that today. All right, so here's some here I'm just going to go through 3 questions. The first one is looking at the making a standard solution, but just remember, I've been doing this for a while, so my hands are freezing, so excuse my bad handwriting, but you need to be able to remember these two equations. Okay, N equals CV and N equals small m divided by big M. So C stands for concentration, which is measured in moles per liter. V stands for volume. Okay, so here's a question. We got 0.189 grams of sodium carbonate, which is dissolved in 200 ml of water. So one thing that you need to be able to do is to coming from level 1 science from last year, from mechanics, you need to be able to look at the unit and identify what that number means. So 0.189 grams is the unit for the mass. So this is small m, and if you look at this one here, 250 mils, this is the volume, and calculate the concentration. So I need to find the C, and then you have the big M here, which is given to you. So whenever you see grams, we always want to convert that grams to moles. And how do we do that? You just use the grams divided by the molar mass, because the molar mass is always given to you, so you can calculate it that way. So 0.189, I'm just going to do it on my calculator. You can do it on your calculator as well. Now on my calculator it shows 1.783, and with a lot of numbers behind it, and then it says E -03. All right, I'm just copying what it says on my calculator, because I get asked these questions heaps. Like, people always ask me, what the heck is that E? That E stands for exponential. So actually, so this is what it shows in your calculator. It says 0.1783 blah 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 blah, a lot of other numbers beside. So we're not going to write this number on paper, because that's what the calculator displays. You can write it like this: 0.78. That E is simply exponential, which means 10 to the power of -3. Okay, so this is how many moles you have. And what you want to do, a really good habit to have, is to keep, well, not a good habit, you need to be able to do this. You need to round to 3 significant figures, and even if your the number throughout your working isn't rounded to 3SF, that's okay. We want the final answer to be rounded to 3SF 100% of the time, okay? But what you need to be able to do, so if I look at my calculator, it actually says 1.7830188868 times 10 to the power negative 3. What you want to do is that you need to use the entirety of the number to do the calculation. Okay, so that's how many moles I have, and I know how many moles I have now, so that's how many moles 0.189 grams is, and then I can do N equals CV. Because I already know the V, I know the mole, I need to figure out the C. So C is a subject. And again, if you're not so mathematics, mathematically talented, if you struggle with math, rearranging equations is not your favorite type of question, you can simply do this. You can just write down what numbers you know. 1.78 times 10 to the power negative 3 equals the concentration times the volume, which is 250 mils. Now, we don't like mils because that unit is too small. We like liters because everything is measured in moles per liter, grams per liter, liters, so we don't like mils. Okay, so this is 0.25 liters. So how do we calculate C? So make C the subject. That means 1.78 times 10 to the power negative 3 divided by 0.25, and then you get the answer. But if you are using a graphics calculator or any calculators you have, you don't clear your calculator. So what it means, guys, is that you need to use the entirety of the number that you got from your previous calculation. So so on my calculator, just say 0.189 divided by 106, then I get that 1.78 blah blah blah, that entirety thing. I just leave it there, then I press divided by 0.25, and then I get 7.13 times 10 to the power of negative 3 moles per liter. Okay, and again, if you're not so confident with the math, you don't have to write it as 7.13 times 10 to the power negative 3. If your calculator is showing you this is perfectly fine as well. Okay, so they mean the same thing, because if you have a lot of zeros before your first number, it's better to write in standard form. It's just neater. Okay, so what is again the purpose of making a standard solution is that we know this concentration, because now for every single mil or every single half a mil, every single drop that you get out of this 250 mil volumetric flask, the concentration is going to be 7.13 times 10 to the power negative 3 moles per liter. Okay, so you know that concentration, and then you can see how many mils of this it requires to neutralize like a known, like say 20 mils of HCl, and then you know the concentration of HCl, because we can use that to demonstrate. We can use this calculation to demonstrate that part. Okay, so this is a full-on calculation question. Now, I can use this question to go through quite a few things. Now, so depends on the school, but I reckon most schools that do this, you will get a theoretical question, and you will need to so what it means is that we give you all the numbers, and you will need to do the calculations. You don't need to do the practical, you just get the answers. And then there will be questions where you need to do the titration, where you need to show that you can get concordant titers, and then you use the numbers you got to do calculation again. So let's go through this one. This is the theoretical one, obviously, because I can't do practicals with you online. So this is 25 mils aliquot, so 0.158 moles per liter of NH3. If you can hear diggers outside, they're just building houses in Flatbush. That's what they always do. Just ignore that. So titrated against H2SO4 solutions. The tidal volume is thus, and you got the equation. We want the concentration of H2SO4. So there are a few things that I will strongly recommend you to do, because as a teacher that's been doing this for quite a few years, the most common mistake people make is that they don't remember what these mils and moles per liter, what the numbers are for. And I personally like to do this. I just highlight the two solutions that we are dealing with. So one is NH3 and one is H2SO4. So if you're someone from my class, you would know, you'll see this all the time. That's a very bent line. I do this. Okay, I just put them right next to each other, and I just write down the clues. Okay, so what do I know? So I look at NH3. So what is this number for? 25 mils of NH3. So this is the volume is 25 mil, which is 0.025 liters. And what else do I know about NH3? I know the concentration. The concentration is 0.158 moles per liter. So if you do it like this, do it like what I did, guys, you will never make the mistake of incorrectly place the volume or the concentration for the wrong species. Okay, because it just saves you so much trouble. Just read, because sometimes, as you can see, all the numbers are muddled up. All the sometimes your teachers like to give you long paragraphs. Just go straight to the unit, look at the number, and then read the line, and then identify what that number is for, and then write it down in a little table like this, just to remind you what the number is being used for. Okay, now what are we trying to do? We're trying to calculate the concentration, so we don't know this concentration. Now, and then the titer volumes, and this is where people get confused. What they get these titers and like, what is a titer? I don't know what was in the period. Well, you only have two solutions. One of them you already know, 25 mils, which is from the pipette. So this must be the titer. This must be the titer. So what you need to do is to look at these numbers and choose three numbers that are concordant. Now, what does concordant means? That concordant means that your largest number minus the smallest number must be within 0.2 mils. So straight away, I hope you can see this guy right there. That number is not concordant, so we don't include that in our calculation. So that is the same thing when you do your titration calculation, when you actually do your titration theory as well. If you get three titers, like say for example, if you were someone like this, if you got 10.00, 10.10, 10.30, well, it doesn't matter what school you go to, you can kiss an excellence goodbye, because what happens is here is that this titer and that titer are 0.2 mils away from each other. So you got unconcordant titers. So the concordancy is not there anymore. So that means the highest you can get is a merit. Okay, so what would you do in this case? I'll do another one. Like say if you get 10.20, then for the next one, then you can have a choice. You can pick this one, this one, this one, or you can pick this one, this one, this one, and then you just have to pick the concordant titers. And with these calculation questions, we normally, at our school, what we try to do, we normally just chuck in some extra titers in there just to confuse them. Okay, all right, so once you figure that out, so that means our titer is going to be 28.65 plus 28.45 plus 28.5, and I need to add it up, divided by 3. And believe it or not, I actually had someone that added up the numbers and never divided by 3, and then that person's titer was like 60 something, and it was incredibly, and that person was really confused and panicked and didn't do so well. So always remember, you're trying to find the average. Okay, so let me divide it by 3. So the titer I got is 28.53 reoccurring. Okay, now one thing that I like to point out, I think we'll show this in the next question. Yes, so I'll just do that later then. But I like to keep my mils, the volume, into dp rather than 3SF, because your burette measures to 2 dp, so I will keep it to 2 dp. So when I convert this 28.53 mils to liters, it will be 0.02853 liters. Okay, all right, so I know this titer now. The titer is 0.02853 liters, and let's do the calculation. So if you know the V, if you know the C, don't forget your magic equation, which is N equals CV. You can figure out mole straight away. So how do we do that? So just N equals C times V, so 0.025 multiplied by 0.158, and that means you get 0.025 times 0.158, you get 3.95 times 10 to the power of -3 moles. Okay, so this is, so this is a mole for NH3. Okay, now I need to find the mole for H2SO4. And this is where you need to go to the equation and look at the mole ratio. Can you guys see that on there's 2 moles of NH3 plus H2SO4. I don't care about the rest. This is the only thing I'm looking at because these are the 2 solutions I'm interested in. Can you guys see there's a big 2 in front of the NH3? So what that means is that the mole ratio is 2 to 1. So that means for every 1 mole of H2SO4, I need 2 moles of NH3. So that means your NH3 number, the mole number, is twice as big as your H2SO4. So to get to that, because this is a 2 to 1 ratio, I need to divide it by 2 to find the mole of H2SO4. So I'll put it here. The mole for H2SO4 is going to be 3.95 times 10 to the power negative 3 divided by 2, because if you just need to look at the equation. You need to look at the equation and think about which one has a number 2 in front of it. The one with the number 2 in front of it means you need twice of that to balance the other one. So that means that thing is twice as small. Or you can think of the H2SO4 in this case. 1 mole of H2SO4 requires 2 moles of NH3 to neutralize, and it doesn't matter how you figure it out, because with ratios there are multiple ways, like different people think of it different way, but this is what works for me. 2 moles of NH3, 1 mole of H2SO4. I already know how many moles I have, so to go from that to that I need to divide it by 2, or you go the other way, you multiply by 2, but we don't need to do that here. Okay, so just use that number in your calculator, divide it by 2, and I get 1.975 times 10 to the power negative 3 mole. And you may go, oh, that's not 3.7, it should be 1.98. It's not part of the, it's not the full answer yet, so you can get away with doing that here. All right, so I'm going to use a different color pen. Let's do this one. Let's do rainbow green. All right, so how do I figure out the concentration? The concentration equals, again, N equals CV, so concentration equals N divided by V. So where's the mole coming from? The mole is here, which is 1.975 times 10 to the power negative 3 divided by 0.02853. And again, you want to use entirety of the numbers. So that means 0.2853 reoccurring, and the answer is going to be 0.0692 moles per liter. And this is my final answer. Okay, so that's what the titration question would look like, and so you need to be able to do this. So what is the practical component? The practical component means you need to get this titer yourself. The theoretical component is just the theoretical part of the question is just that we give you all the numbers. You don't need to do the practical. Can you figure out the concentration of the unknown solution? Okay, so that's that part. All right, one last question. So this is more of a if you look at this is more of a like a complete example. So this person did, all right, so this is what I tend to do. I read this and then I just start highlighting 0.235 mole HCl. So I know my concentration HCl. So why don't we just do this straight away? Why don't we just get into the habit? What do we do? Unknown concentration Na2SO4, Na2CO3. So Na2CO3. So there we go. So what do I know? Concentration. Just write it down as you go. You can put it down on the back of the booklet or something, or ask for an extra piece of paper. Just write it down. All right. Now, what else do we know? When we use and titrate this into a flask containing 25 mL pipette volume of unknown concentration of NH. So that means this volume is 25 mL. Okay, because if you read the sentence, 25 mL of unknown solution Na2CO3. So this is 0.025 liters. Okay, so what does that mean? That means this titer, can you guys see this titer stuff? This is our titer. Where will that go? That titer will become this volume. So we can figure out, we can use these numbers here from the table to figure out the volume. Once we know the volume, we know the mole. Once we know the mole, we know this mole. Once we know this mole, we can figure out the C. Yeah, can you guys see how we solve questions like these. It's gonna make your life a lot easier if you just follow this particular method. Okay, so let's do some calculation first. This is a final reading of the period, initial reading. Now, if you look at the table, this is what you should be. Everything should be recorded into dp. Even though your last number is a 0, you should always record it to dp, because that's to do with accuracy, especially if you do physics, because they're quite big with uncertainties and all that sort of things. But in chem as well, because we always measure to the lowest unit, so 2dp is a must. And the last number should either end with a 5 or 0, because if you, like say for example, this is 19, this is 18.95 and 18.9 for example. If your meniscus is like over here, then this is 18.95. Okay, so you end with a 5. Don't tell me that you can read that as 18.93. You can't really physically see that with the burettes, with the human eyes at least. If you could, then we probably want to do some research on your eyes, because you got some supernatural amazing eyesight. But as far as I'm aware, we can't really see that. Okay, so 2dp, last number should be 0 or 5. Okay, so final minus initial, this is going to be I normally do it in my head, but since I'm recording, I don't want to make a fool of myself. This is 18.660. This is 18.50. This is 18.85, and this is 18.38.4 minus 19.85. This is 18.55. Okay, sorry, that's a bit small. Now, so this is 18.6, 18.6, 18.50, and 18.55. That looks like a 3. My apologies. I'll just probably redo that. This is 18.55. Now, not sure if you guys can see, but this guy 18.85 is not concordant. Okay, how do I know it's not concordant? Because this is too big compared to any of the other titers. They're not within 0.2 mils, so we're not going to use this. Okay, so select the appropriate titers, calculate the average titer. So it's going to be 18.6 plus 18.5 plus 18.55 divided by 3. You actually don't need to do this. This is just going to be 18.55 mils, which is 0.01855 liters. Okay, so that means this number is going to be 0.01855 liters. Now, it depends on what school you're at. We tend to break it down into questions like this. Can you guys see we're just prompting you how to do these? I used to just give my guys, just do the table, everything's in there. But then we try to show get you guys to show more evidence in terms of your thinking, because some of my students were really lazy. They literally just put the answers in here, which is not ideal. Okay, so calculate the moles and equal CV. So you're literally just using this this concentration, this volume, which is 0.235 times 0.01855, and then you should get 0.235. Oops. Times 0.235, you get 4.36 times 10 to the power negative 3. I round to 3 but it's actually 4.35925. Okay, I recommend you to do this on your calculator, because being able to use a calculator is actually quite important. All right, so we know this mole. If we know this mole, we want to calculate the amount in moles of sodium carbonate. So this is where you need to go to the equation. You need to look over here. This is that and that. And ask yourself, okay, so the 2 HCl, so this means this is 1 to 2. That means for every 1 mole of Na2CO3, I need 2 moles of HCl. So how many moles of HCl do I have? I have this many moles of HCl, so I need to divide it by 2 to go to the Na2CO3, because the HCl mole, this number, is twice as big as your Na2CO3. So this is going to be 4.36 times 10 to the power negative 3 divided by 2. Now, I'm not going to use that number that's displayed on the screen. I'm going to use the entirety of the previous calculation. If you're not sure what it is, this is 4.35925 times 10 to the power negative 3. I'm going to use this for this calculation, but on paper I write that. I mean, if you really want to, you can write 4.3595925 here as this particular answer. That's okay, because it's not your final method. but I'm just used to writing 3SF whenever I go. So this is going to be 2.18 times 10 to the power negative 3 moles. Again, I'm keeping the whole number, which is 2.179179625 blah 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 blah. You know, you can look at that on your calculator. All right, so we got this mole, so we got this mole, we got this mole. Now we need to find the concentration. How do we do the concentration? Concentration equals mole divided by volume, which is 2.18 times 10 to the power negative 3 divided by 0.025, because all the numbers are right here, and then that will be 0.0872 moles per liter. Okay, and that's your final answer. All right, so with these type of calculations, just go with the table that if you're really struggling with it, try to do the table, because you're only needing to use one formula, which is N equals CV for this type of calculation, and it's really not that difficult. Okay, so that's that part. Now let's go scroll down a little bit for the final section. This part is one thing that we are quite big on for this particular section, which is dilution. Okay, so for dilution, why do we need to dilute? Because your teacher should tell you that, and this range varies. I say 10 to 30, some people say 5 to 25, some people say 8 to 30. It doesn't matter. It's about 10 to 30 mils. So what that means is that when you do the titration, you guys should have done some titrations by now. You will know that the burette is about 50 mils, takes about 50 mils of liquid. And for time efficiency wise, you don't want the titer to be too big. I say if you have a titer of 45 mils, that's way too, if you have a titer that's too big, like say for example, if your titer is too big, that means the solution in the flask is too concentrated. Okay, so that's because you're requiring too much liquid from the burette to neutralize the thing in the flask. So that, in hindsight, that means the flask solution is too concentrated. So that means if you want this to be, you need to dilute this. You need to dilute whatever was in your flask, and then you can achieve a lower titer. Because if your titer is too big, too much uncertainty, you're more likely to make mistakes. We don't want that. If your titer is too small, if your titer is too small, for example, if it's like 1 mil, that means your solution in the burette is too concentrated. Yeah, you're using so little to be able to neutralize the thing in the flask. That means it's too concentrated. All right, in the burette is too concentrated. So what you want to do is that you want to dilute. You dilute this guy. Okay. In most cases, I'm pretty sure you will often find a titer that's too big. Like say, if you set up your burette, you ran the entire solution, like 50 mils of solution into the thing, and it still didn't change color. That means your solution in the flask is too concentrated. Stop doing titration. Get the original solution in the flask and dilute it. Okay, so dilution is, you can do it 5 times, 10 times, 20 times, 25 times, 50 times. You can do it however you want. And what it means by 20 times, it just means it's diluted 20 times. So that means it's 1 to 20. And how you can figure out this, let's just do the calculation first, and then I can show you how to do dilution really quickly. So it was diluted 20 times, so that means the original solution was 20 times more concentrated. So that means it's 20 times more concentrated. Use the exact number that you got from last time, multiply by 20, you get 1.74 moles per liter, which is quite concentrated. Okay, and then the last step, because if you with the moles per liter section, if you go to, like say, if your parents don't do any science, if you tell them they do learning chem at school, and you're finding out this concentration is like 2 moles per liter, that's really concentrated, they'll probably just look at you like, what the heck are you talking about? What is a mole per liter? But this is why we convert moles per liter into what we call the mass concentration, which is grams per liter. Okay, so how do we do that? So to go from moles per liter to grams per liter, what you want to do, and should I show you? I'll just quickly show you. So you want to convert moles per liter to grams per liter, and you need the molar mass. This is why we give you this. Ignore the subscript. I didn't forget to change it. So you want to do this. So what you want to do is that you want to multiply by the grams per mole. Okay. So in short, just multiply. So use your moles per liter, multiply by the molar mass, and that will give you the grams per liter conversion. Okay, because anyone should be able to understand grams per liter. So it's 1.74 times 106. Again, I'm using the entirety of the numbers on my calculator, so that will be 185 grams per liter. So what that means, if you have 1 liter of solution, there's 185 grams in it. Okay, so let's look at the dilution really quick. So how do we do dilution? Dilution is, like, say if we want to make a 20 times dilution, for example. How do I do it? If I figured out that, yep, my titer is way too big, my titer is like 55 mils plus, that's horrible, you know, I want to dilute the thing in the flask. So what do? So what you want to do, you normally get given a 250 ml volumetric flask, so you get a 100 ml volumetric flask. It doesn't matter what size it is, you just use the apparatus you have, and then you want to divide by whatever number you got. I say if I want to do 20 times dilution, so I do 250 divided by 20, which is 12.5. So that means I have 12.5 mils of original solution. So what does that mean? So you are going to go measure with a measuring cylinder, get 12.5 mils. You get 12.5 mils of solution of the original solution that you know that's too concentrated, and then you are going to add it into the 250 volumetric flask, and then you're going to top it up with water. So you're going to top it up with 237.5 mils of water, and that's going to give you your 250 mils. So you like, do I have to measure this? Not really. You should have used a volumetric flask by now. So you literally just measure 12.5 mils of the original solution, pour it in, pour it into the flask. You chuck that in there, so that's 12.5 mils. This is your little ring up here. So you just add water. You just keep adding in water until the ring, the meniscus is above the ring, and that's your solution. That's 20 times diluted. Okay, and you may go, what about 10 times dilution? You just divide this number by 10. What if you want to do 5 times dilution? Divided by 5. What about 50% dilution? Divided by 50. And that will just use the apparatus that you got given, and then that you can figure out how much of the original solution you need. Okay, so hopefully this has been helpful, because with the reporting, normally I hope your teacher will be able to give you, in terms of what to do with the report. How do you write the control variables, the method, those are quite straightforward, but then the practical and the calculation are the parts that people most struggle with, and I hope the last couple of videos have been helpful. Okay, so enjoy the holidays. Well, I'm on holidays, so I'll be uploading more content during the next couple of weeks, and I'll see you guys next time. Right, bye-bye.